All right, thanks again, everyone, for joining us. This is the navigating updates and implications of MSHA's Final Silica Rule. So we hope that we give you some good information and answer some questions for you. My name is Andy Bragg, and I'm the Director of Sales for SKC, and I will be presenting a short section on air sampling today at the very end. So again, I want to thank you for your time and attendance today. I want to introduce our panelists and our presenters. Saulius Trakumas wears several hats for SKC. In addition to being a panelist for today, he is also our head engineer, and he is an aerosol physicist, and his official title is actually Product Development Manager. So we're very grateful to have him available to answer questions and as a panelist today. Beth Sackett is also a panelist and will be managing the incoming questions in the chat area. So please feel free to enter any questions that you have in the chat whenever necessary. Beth is the president of SKC West, and her team does a phenomenal job of serving the West Coast customers for SKC. So we're grateful to have her today as a panelist as well. And last, and certainly not least, Dusty Ott will be our main presenter today. Dusty is the corporate CIH for SKC, and Dusty has extensive experience in practical industrial hygiene, including as a civilian in the military, also in oil and gas, and most applicable for today, he has several years experience in the mining industry. So we have a great group for you today. Please be sure to ask any questions in the chat area that you have. And at this point, Dusty, I will hand it over to you.
Awesome. Can you see my screen, Andy?
Yes, I can.
Awesome. Well, thank you all for joining today. Like Andy said, I've been lucky enough to spend some time in the mining industry, both underground, process, and on surface. So that is where I'm coming from today for this presentation. And the main key takeaways that I want to get out of the way right up front is there is a lot of information in this presentation. We're not going to have time to go through every slide word for word, and nor would I think you would want that. And so I will be breezing over some of the slides that have a lot of information. But just know that this presentation will be available after this webinar, and so you can go through it at your leisure and go through everything you could want as much as you want. So with that in mind, we're gonna hop right into it. So a quick summary about what we're gonna do. We're gonna cover a little bit about silica and why it's bad to breathe, a quick introduction to the new Pell from MSHA, as well as how to convert some results into an 8-hour time-weighted average from a 12, 11, or 10-hour shift. We're gonna go over the rule itself, which is why I think most of you are here. Quickly, we're going to go over some size selective sampling and why that's important for the rule. And then Andy's going to take it from there on how to correctly sample for silica. And so with that being said, silica, most of us know, is not something that we want to breathe. It is not a good substance. It's small, it's sharp, it travels deep down into our lungs and can create some serious issues over the long haul. And so here are a couple pictures of some silica under a micrograph. We're specifically talking about respirable silica, the ones that are small enough to travel deep down into our lungs. And I always think of these as little arrowheads, that they look like little pieces of obsidian that are going to impact in our lungs and going to create some issues for us long-term down the road. So as far as the mode of damage goes, as you can see from this picture, we breathe in silica. It's going to go down into our mouth, through our trachea, down into our lower lung, into the alveoli, which is where we actually breathe. And that is where the silica is going to do the most damage. It's going to create scarring, some fibrosis, and ultimately it's irreversible from an exposure and health point of view. So this is an incredible picture that I've never seen before up until these last couple of presentations, but this is a picture of a white blood cell getting ready to engulf a piece of silica. And what happens is when our white blood cells deep in our lungs go in and engulf that piece of silica, it's going to kill that white blood cell, which is going to create a triggering response and it's going to call other white blood cells to come to the site to try to help get rid of that piece or pieces of silica. And as more and more white blood cells come, more and more white blood cells die. And over time, fibrosis and scarring can lead to a decreased lung function, and it takes the elasticity out of our lungs and make them much stiffer, so it's harder to breathe. And so the scary part is that last point where it says this process can happen even after silica exposure has ended. And so even if you have a lot of good controls put in place after years and years and years of unprotected silica exposure, that mode of damage can continue to happen. So it's something that MSHA is very, very aware of, and it's something that kind of oozes through the entirety of the rule of their, it's very important for them to reduce exposures to not only existing miners, but to new miners coming into the industry. And so as far as a size of particles go, I love this graphic, and I placed in the middle of it the respirable crystalline silica particles. As you can see in the slide, they're between 1 and 10 microns in size. You'll notice from the red circled part that there's a split to where we can no longer see those things that are smaller than about 15 microns, which is about the size of pollen. And so you'll look at some of those smaller particles, and some bacteria are 1 to 3 microns long, and some of our silica particles are as small as bacteria. So we're talking about things that are incredibly small and things that travel deep down inside of our lungs and do their damage. So before we get too far into the rule, there is a term that is, if you're an industrial hygienist, it will make perfect sense. If you haven't been in the mining industry or you're not super up with metric units, this might be a little confusing. So I wanted to go over it so we can make sure that we're all on the same page. And that is micrograms per cubic meter. And what we're talking about, it is a mass to volume concentration. It's how much of something is in a given space. And so to kind of help give some context to this, if we look at, if you take some salt or sugar packet and put it on your table, about one of those crystals is about 50 micrograms. And so it is, I mean, a microgram, it's a millionth of a gram. Like it is so incredibly small that it's hard to completely wrap our minds around. But looking at a grain of salt or a grain of sugar, we can see that is about 50 micrograms. And so how big is a cubic meter? It's about that big. It's a meter by a meter by a meter. For anyone who doesn't speak metric, it's 1.3 cubic yards. And I had to throw in a little kudos to our good friend Diet Coke. It'd take 1,000 Diet Cokes to have the same volume as a cubic meter, because each Diet Coke is approximately, it's 1 liter. So the correlation between the two is we have basically you taking 1 grain of salt or sugar and you're evenly distributing that within the space of 1 meter. And so if you could completely aerosolize that little grain of sugar or salt or silica and evenly distribute it throughout that meter, that is the concentration that we are working with. It is at a level that you cannot visually see it because the particles are so small. And so if you are in a very dusty area, typically all those particles are in the visual range because you can see them. And just because you go into an area where you can't see any visible dust, it doesn't mean that it's there. And so this is another fun graphic. I took this picture last week to kind of make it a little bit more real. I put some flour on Mr. Abraham Lincoln's head, and you can see that if you were to take that much silica and you were to completely aerosolize it in an average office room or average office, you would be overexposed to the new MSHA PEL. So again, it does not take very much, and it is a very, very small amount. So as we've alluded to already, the new Pell from MSHA is 50 micrograms per cubic meter, and the action level, or the level in which you have to take some type of action, is 25 micrograms per cubic meter. And the kicker is this is averaged over an 8-hour shift. And so you're all thinking to yourself, well, there's no one that works 8-hour shifts at the mines, and I totally get that. And the reason that the MSHA did this is it gives us a constant number that we can compare our results to. Back in the day, when you took your respirable dust and silica samples, it seemed that your silica samples would always have a different PEL based on the percent silica in your sample. It was always kind of a moving target. It was always involved some extra math to get your new PEL to compare it against. And so what they've done is they've given us all a level that we can all convert our sampling results to compare against the new Pell. In my mind, it makes more sense, and it's simpler and easier to do. And so what we're going to do is we're going to quickly walk through where this information came from and how we would actually calculate an 8-hour time-weighted average based on some sampling results that we would get back from the lab. So this is an example of a lab report that we would get back. In this red square, this is how many micrograms of quartz silica is actually on that cassette. And given our volume of air, this is what the resultant concentration would be. And so knowing that the new exposure limit is 50 micrograms, initially we would look at this, be like, wait, I'm at 38.46 micrograms per cubic meter. I'm well under the new limit. I don't really need to worry about it. Well, it's not quite that simple. And so what we've done and how this is calculated is you take how many liters of sample that you took for your volume, and you're going to convert that to cubic meters. And if you remember earlier, we know that there's 1,000 liters or 1,000 Diet Cokes per cubic meter. And all we are doing is we are taking our total mass of the volume in the mass of the sample, which in our example is 50 micrograms right here, and you're dividing that by the total volume. And that's where we get the 38.46 micrograms per cubic meter. Now, this is where it kind of gets a little more interesting. And as you can read in this slide, it doesn't matter how many minutes you actually worked in your shift. We are going to divide our total mass by 480 minutes times our flow rate. In this example, in the rule, MSHA uses a 1.7 liter per minute flow rate, and the resultant corrected value is you end up having a 67.4 micrograms per cubic meter if the result on your filter paper was 55 micrograms. And so this is a little confusing to wrap your mind around, and so we're going to take a little bit different approach and approach it in a way that I think makes a lot more sense and easier to calculate. And so on the top of the screen here, you have the same formula that is in the final rule from MSHA. And what we're going to do is, if you remember from our previous example, we have 50 micrograms on our filter paper or on our cassette. And so what we're going to do is we are going to convert this 12-hour result to an 8-hour equivalent that MSHA has asked us to do. And so for our example, we had a 2-liter flow rate. We're changing it to 8 hours, which is 480 minutes. And then this value right here, this converts your cubic liters into cubic meters. And so what I thought was really interesting as you're going down and doing the math is that you're taking how much mass was on your filter and you're dividing it by 0.96. And if you're familiar with math at all, if you divide something by 1, it always ends up being itself. And so 0.96 is almost 1, which means that it's a very close value to what we're trying to get from an MSHA point of view. And so converting our example into an 8-hour equivalent turns into being 52.08 micrograms per cubic meter. Now, this next slide, I think, makes it a little bit visually easier to understand. So this, on the left side, this is the amount of mass of the silica that was on the actual cassette. The results that we had, that the lab calculated was 38.46, but once we convert that to an 8-hour time-weighted average, you'll notice that if you start out with 50, you end with 52 micrograms per cubic meter. And the same thing with the action level amount. If you start out with 25 micrograms on your filter, once you convert that to an MSHA equivalent, it's 26. So it's, in my mind, using a 2 liter a minute flow rate cyclone or PPI allows you to very simply look at your results and know, almost by looking at them, if you are under or over or somewhere in between the action level and new PEL. It's something that I hope you take some time to go through and understand, because it makes a lot of sense to use a 2 liter a minute flow rate versus something else where the math is much more different. So moving on to the actual final rule. If we have any dodgeball fans on there, you can appreciate Mr. Ben Stiller getting ready for the hurricane. And I had to chuckle a little bit because going through this rule, it kind of felt like a hurricane. Things were all over the place. Didn't really make any good rhyme or reason where things were where they were. And so as we go through this rule, I've put section numbers, I've put page numbers, so it'll be easier for you guys to go back and reference and look through and find a little bit more information in those areas. And so again, something funny is the numbering system. I don't completely understand it. It goes from 1 and then 2 and then 10. So somewhere 3 to 9 are missing somewhere in the void. So let's hop right into this. So quickly, there's a couple changes between the proposed and final rule. I'm not going to read through every one. Most all of them will be covered as we go through them. The link that I've included here is a document that MSHA has provided that goes into some good detail, and you can find some additional information. The main differences is they changed when and how, or they changed the new timeline for when we have to have sampling in place. Basically, for metal and non-metal mines, it is 24 months. If we're talking about the coal mines, it's changed to 12 months. Initially, that was 4 months and 6 months. So they definitely gave us a lot more time than we originally planned for. We can no longer use objective data to compare samples against. And any samples that you get that are over the new PEL, you have to report those immediately to the MSHA district manager, which is very different than what the proposed rule said. And then I'll let you all go through this on your own time. There's some more information, but we just don't have time to go through all of it. So 60.1, like I alluded to earlier, coal mines are given 12 months and their effective date is going to be April 14th, 2025. Metal and non-metal mines were given 24 months, which bumps us out to April 8th, 2026. And in the preamble, it gives us some ideas and clues as to why they pushed out the timelines the way they did. I can appreciate them doing that because there was a lot to do in only 4 months if that was if that was what we actually had to do based on the proposed rule. And so what I think is interesting as you read through this, they're giving us so much more additional time to comply with this, but at the same time, there's a lot of provisions that are in this rule that do not even exist yet from an MSHA point of view. For example, in the medical surveillance section, there is a part that references sending x-rays to a NIOSH database, and they even note that NIOSH has not yet developed this database. And so a lot of information will be coming to us over the coming months and years before our deadlines hit. But just know that we have time right now to get into compliance before that hits. And so if there's no other thing than you hear of this webinar, the one thing that I want to make sure you understand is that we have been given either 12 or 24 months, depending if we're metal or non-metal or coal, to get into compliance. And I'll get into this a little bit more in the presentation, but right now really is the time to act. You know, initially people think we have 24 months to comply. I have so many other things to do. I'll just push out, I'll procrastinate. I'm not going to worry about this for another couple of years, at least a year. What's going to happen is as we get closer and closer to that day and more mines start to sample and find out that they're overexposed and they need to order a bag house, they need to order equipment, they need to order additional water trucks, whatever it might be, you know, they're going to be ordering as well as everyone else is going to be ordering. And if the pandemic taught us anything about supply chain, it's going to get very interesting. And so if we take the time now to prepare to do our sampling, to find out what areas are going to be high so we can start working on those controls right now, it'll be so much better when the rule comes into effect in either 12 or 24 months. And a good thing to think about it is MSHA has given us this time to come into compliance. I can't imagine they're going to be very patient if they come in and after 24 months we haven't done anything, and then the likelihood that we're going to get some additional citations is much higher. So again, if there's one takeaway is don't waste your time. Like start now, start sampling now, start identifying high areas now, and getting those controls into place before the new rule hits its effective days. So as we've said a couple times, the new exposure limit, the new PEL, is 50 micrograms per cubic meter. So as far as the methods of compliance goes, MSHA has asked us to install, use, and maintain feasible engineering controls. As we'll get to a little bit more in the presentation, respirators are not a feasible control. They are a temporary control, something that's not to be used in a long-term solution. So that is, you know, water, baghouses, anything you can think of that will reduce exposure from an engineering point of view, and does not require somebody to physically put something on or do something they've been asked to do. And lastly on this one is the rotation of miners is not acceptable. If after 4 hours you know that your crusher operator is overexposed, you can't just pull him out and put somebody else in to take his place. You have to figure out some other means to control the dust in that area. So as far as the exposure monitoring goes, one of the things that they changed from the proposed rule is there's no more talk of baseline sampling or periodic sampling. MSHA just calls everything sampling. And so with that in mind, there's 4 different sections of exposure monitoring in the rule that it talks about. The first one is just sampling. The next one is corrective action sampling. And so when MSHA says sampling, they mean full shift. They mean for each miner who is or may be reasonably expected to be exposed. And over on page 28292, in the preamble, it talks about that anyone in extraction is going to be someone who's reasonably expected to be exposed to silica. So, and we'll get more into corrective action sampling as we go. So these first ones were actual sampling. These next 2 are more qualitative evaluations. And so in part C, it talks about every 6 months going in and having a evaluation of the area, walking through the area, seeing if there's new things that are in the area that may overexpose somebody or increase their exposure to silica. And based on that evaluation, then some additional post-evaluation sampling may happen. And so again, this will, we'll talk a little bit more about this as we get through, but these are the main 4 points from the exposure monitoring that the MSHA has in their new rule. And so the way that I like to think about it in the first section is I made this little MSHA compliance-o-meter. If you are below the action level of 25 micrograms per cubic meter, you are in a happy spot, you are good. If you are in between 25 and 50 micrograms, which is above the action level, but below the PEL, you're going to be doing some additional sampling every 3 months until your exposure is below that to get you out of that sampling cycle. And then anything above 50 micrograms per cubic meter, you're going to kind of be in a place that you don't want to be. So to add a little bit of character and a little bit of fun into this part, you know, I would rather much be like Mr. Snoop Dogg, partying down in below 25 land, rather than being with Mr. Office Man, who's you don't want to be there. And I think as we get more into the actual compliance sampling and the corrective action sampling later on, you'll see kind of the reasons why you do not want to be stuck in the above the Pell cycle of doom. So if we take a sample and it comes back below the action level, this is very good news. What you're going to want to do is take an additional sample within 3 months, at least 7 days from when you got your last sample, to make sure that you are under that 25 micrograms per cubic meter. If you have 2 samples in a row that are below 25, you can discontinue sampling, which is great. If you end up in the zone, the yellow zone between 25 and 50 micrograms, you're going to go back and you're going to sample again within 3 months. If your sample comes back and you're still in that 25 to 50 microgram range, you're going to come back within 3 months and sample again. And you'll continue sampling until one of those samples gets below 25 micrograms. Once one of those samples gets below 25 micrograms per cubic meter, you're going to sample again. And if the next sample again is also below 25 micrograms, you can discontinue sampling at that point. So if we are above 50 micrograms, this is where we start entering into that area that's not very fun to be in. So again, on this slide, there's a lot of words, but basically you're going to sample. If you're above 50, you have to immediately put in a corrective action and immediately notify MSHA that you have an overexposure. Then you're going to resample once you have that corrective action put in place. If your results come back and you're still above 50, you're going to do another corrective action. You're going to call MSHA and say, hey, I'm over again. I'm going to resample. And that cycle will continue until you are below that 50 microgram range, until you're in that 25 to 50. And then it's going to follow that same pattern as above. If you continue to lie in that 25 to 50 microgram range, then you are going to sample every 3 months until your samples are below 25. And then if you keep below 25, then you're going to take one more so you can discontinue sampling. So methods of sampling analysis. This is good information that you can look through later on. Basically, your lab has to be accredited to an ISO 17025 standard. And then as far as some sampling requirements go, your samples have to be on the same shift in the same work area doing the same work. And this picture that I found, I think this would be a perfect example of some representative sampling from people that are on the same shift, same work area, doing the same thing. So as far as what kind of sampling devices can we use, they are very specific, and that it has to conform with the ISO 7708 1995 respirable curve. And so it calls out a couple specific ones in the rule of what would be acceptable. The ones that they say they specifically call out are the Oliver cyclone, the Higgins dual, the SKC aluminum cyclone, as well as the PPI sampler. But I want to make sure and point out that in bold, as long as the device is designed to meet the characteristics for the respirable particle size selected samplers, it can be used. So even if you have samplers that are not listed in this list, as long as they conform to that ISO curve, you will be able to use them. And if you look at page 28331, almost the entire page is addressed to answering that question. So as far as real-time monitors, there was some questions in the proposed rule if we'd be able to use these. MSHA said no in the proposed. They also said no in the final. But one thing I thought was very interesting, if you look on this third point, is it says, MSHA notes that samplers taken by operators using the RQM or a real-time dust monitor are not subject to requirements of the final rule. That means that if you use a real-time dust monitor, the mine operator does not need to report them to MSHA, take corrective actions, or conduct additional sampling. And what I mean by that is if you take a sample with a cyclone or a PPI and you find out that you're over the Pell, rather than going back and continually sampling with the PPI or cyclone again, once you make corrective actions, you can use a real-time dust monitor to see if those corrective actions worked. If they worked, great. Go ahead and resample with a PPI or a cyclone to be able to show MSHA that, hey, I proved that I'm under the Pell. I put it into corrective action, we're good. If you put it into corrective action and you use a real-time dust monitor to sample and you're still over the Pell, you don't have to tell MSHA that you are still over the Pell and get another citation. You can continually use this as an engineering control to spot check to make sure that your corrective actions are working before you continue to sample again. So as far as sampling records, this is the bare bones that you have to put on sampling reports, and that's the sample date, the occupation, the concentration, and this is key, respirable crystalline silica and respirable dust. There were some questions initially that are we going to have to continue to sample for respirable dust as long as we're sampling for respirable silica? And yes, you have to continue to sample for respirable dust and crystalline silica, and post the results from the lab as well as the results on the mining bulletin board. So as far as corrective actions go, there is a lot of words on this slide. I'm going to be able to sum it up a little bit easier, a couple slides down. So we're not going to go into a lot of detail, but basically know that if you are over the Pell, that you have to, one, immediately contact MSHA to let them know that you're over the Pell, and you have to make sure that anyone that's working in that area the next shift is going to be equipped with a respirator that they are going to wear properly. And this is something that you will continually do until you are below the Pell. So this is just some additional information on what we're talking about as far as corrective actions go. This in the preamble. The one thing that I want to point out is that on this third bullet down, it says the district manager will take appropriate enforcement actions and may provide assistance depending on the circumstance. And where this will come into effect is this right here. This is your corrective action cycle. And just like that poor dog is chasing his tail, I think there'll be some tasks and some jobs on our mine sites that we're going to feel the same way. You're going to sample if your results are over the Pell. You have to notify MSHA, make respirators available, create an action plan to lower it, execute the action plan, and then resample. And if you're still over the Pell, you have to do that same process again and again and again. And there's not really a way given in the rule to get out of this cycle. I want to just point out again that, right here, the district manager may provide assistance. Not every district manager is going to be the same. Not everyone is going to be as understanding or be willing to help. And so this is a cycle that right now, the only way to get out of is if you are below the Pell. And for a lot of jobs, as we know, that is going to be very difficult to do. So hopefully we have some additional information come from MSHA in the coming months to where we can understand a little bit more of what we can do. If there's nothing we can do, we've thrown tens of thousands or millions of dollars at controls, we're still not over the Pell, what else can we do? So as far as violations goes, it says several times throughout the rule that any time that you are over the exposure limit, it is a violation. And if we have any Dukes of Hazzard fans, you'll know exactly what this picture is about. And so again, right now, for the next 12 months or 24 months is the time to take action and to be able to reduce those exposures, because if you wait until the actual rule comes into place, every single overexposure will be a violation. So getting into the respiratory protection, this is a large section. There's a lot of information. Basically, the key takeaways from this is that respirators are only to be treated as a temporary means of protection. MSHA does not want anyone wearing respirators that does not have to, meaning that right now, if I'm doing a job and there's dust in the air, if I want to put on a respirator, that's fine. Like, they are so against that moving forward, and it says it so many times throughout the rule that as you read through it, their favorite word with respirators you'll find is a temporary solution. And so, well, how long is temporary? Like a short period, a reasonable period, the time necessary. Like they don't give us an actual time frame of how short or long that can be, but it says in the preamble, it goes a little more into it, that MSHA will approach that on a case by case basis. So definitely take some time to read through and understand that, so you're not caught off guard. As far as if there's a miner that is unable to wear a respirator, he's going to have to be moved to somewhere else, either in that mine or doing a different job that does not expose him to silica, until there is corrective action samples put in place and samples taken to prove that the exposure has been reduced, until he can go back into that area. I think it's funny. MSHA believes that it should not be difficult. So as long as MSHA believes it won't be difficult, then of course it will not be difficult. So this was a question that was asked in the proposed rule, and we got some really good clarification in the final rule. Is, will N95s be allowed to be used? And based on the final rule, you have to have a 100 class or high efficiency class of respirator to be used. And it goes on to talk about how the N95s are not allowed. It is something that in the past, you go underground or you go into an area that has a lot of dust in the air, and people would just wear disposable dust masks or N95s in that area. That is no longer allowed. It has to be a tight fitting option. They can be quantitatively or qualitatively fit test to make sure that it is fitting on your face. So the medical surveillance section is quite large. It goes through a lot of detail. The high point is that there is going to be mandatory and voluntary examinations. And so the one point I want to just point out is in A2.3, it talks about how these x-rays need to be viewed by a B reader. Now, I checked yesterday on the NIOSH site. There are 185 B readers throughout the entire country. There's 260,000 miners in the United States. You do the math and you can decide if you think there's going to be enough B readers. MSHA is very confident that there is. I guess we will see if that is going to prove to be a bottleneck. And so again, definitely take some time to read through the medical surveillance side of things. There's a lot of information. Again, we just don't have time to go through that in great detail right here. So like I said earlier, there's a voluntary examination as well as mandatory. And this is the part that any new miner that starts with a mining company is going to have to participate in. So like I said, take some time, digest the medical surveillance side. There's a lot to go through. So moving right along into this next little bit, I want to take a quick moment and appreciate a much younger and picture of myself. This is at Newmont over in Elko, Nevada. This is where I started my industrial hygiene career, and I absolutely loved it. So from moving on from that, talking a little bit about industrial hygiene, is what is industrial hygiene and what does it mean? So this morning I asked Facebook AI to generate a picture of what industrial hygiene was. This is what it gave me. This is what everyone I talked to on the plane thinks industrial hygiene is. And ultimately, in my personal loving opinion, being an industrial hygienist and taking the samples that we've been talking about is your own little form of being a Superman. You're helping people. You're finding out how to lower their exposure and to make their life a little bit better. And yes, in case you didn't know, I was a stunt double in Man of Steel for Henry Cavill before I came to SKC. So it was a very fun job. So quickly getting into some size selective sampling. The reason that we need to select the size is because the larger particles that we breathe in are going to get impacted on our throat and our nose. They're not going to make their way all the way down deep inside of our lungs. And so that is where either cyclones or the PPI is going to only give us the size particles that are going to damage our lungs. And so as a quick overview, the cyclone removes the larger particles by spinning them out of the air, and the PPI removes the larger particles by impaction. And so either way, it allows those smaller size particles to make their way to the actual filter that will be analyzed by the lab, so we'll know exactly how much silica is on that cassette. So quickly, I always like to think of respirable particles as a small, very agile, ninja-like people, whereas the larger inhalable particles, like my lovely little boy, I don't know how many of you have toddlers, but it's so fun watching them run and trying to make the corner, because more often than not, as he's trying to make the corner, he runs into the wall. So that's exactly what's happening with those larger particles in our cyclones or PPIs. So there are some shortcomings when it comes to cyclones. You got to make sure that they're clean. You got to make sure that they're not tipping on their sides or upside down. If you're using cyclones, just make sure you're using them appropriately so you have good and effective results. As far as the, there we go. There is an example of the sampling curves that we're talking about and how well the cyclones are fitting them, as well as the PPI right here is another option that we have. This is an example of how closely it's following that respirable curve. And so it's a very, very tight fit, and kind of like in this slide up above here, the main part I like about the PPIs for a mining point of view is there's no orientation bias, meaning that if this turns on its side, if someone's laying on their back, if they're hunched over working on a piece of equipment, that cyclone or that piece of equipment is not going to turn upside down and drop all your bigger particles onto the filter itself. And so the one key thing to remember about size selective sampling is that it has to be at an exact flow rate. Each cyclone or each PPI is going to have a specific flow rate that is going to make those results possible. And for any of you who have sampled at the wrong flow rate, you know that you probably have never done it again. I remember the one time, one of the first times that I was sampling, I had the wrong flow rate, and therefore the results that I had the wrong cut point, and therefore the results did not comply with what we had to do, so I had to go back and resample again. So lasting shots is when you do sample, just make sure it's at the right flow rate, and Andy will get a little bit more into that in his section. So Andy, that's all you, my man.
Fantastic. Can you see my screen, Dusty?
I cannot yet. Yes, I can see it now.
All right, great. Good job, Dusty. That was a lot. Take a breath. So if you have any questions on what Dusty just covered, now would be a great time to enter them in the chat area, and then we will address those at the end of this short section about air sampling. So Dusty has already done most of the heavy lifting in regards to the changes, but what I hope to accomplish in this short 10-minute section is to convince you of two things. If you do in fact need to perform personal air sampling as part of the new rule, and you haven't done it before, you don't need to be intimidated or stressed out by this process. It is much easier than you might think. Technology is definitely working in your favor. So secondly, I want to encourage you to call on the SKC team anytime you have any questions. It's, you know, there's a lot of daunting things in the rule, especially again, if you haven't done it before, but between our CIH, Dusty, that you just heard from, and our sales team worldwide, as well as our tech services people, we would love to help you and save you some time of searching and wondering and trial and error. So let us help you. So to jump right into this, basically speaking, to start the process of preparing to do air sampling for silica, you need to select the proper air sampling pump, select the proper sampling device or media, which will be what actually collects the sample or the silica onto a filter, and then select the proper calibrator. So all air sampling, oops, it did not change. There we go. So all air sampling pumps aren't the same. So if you just go into it looking for an air sampling pump, you're going to have a lot of challenges because people are going to need to know a lot more specifics. So to give you a heads up, you'll need to spend some time selecting the correct pump for the application. There are low flow pumps, there are medium flow pumps, there are several larger high flow pumps for doing area sampling, but for silica sampling, you'll normally use a pump that can sample roughly between 1 and 5 liters per minute. Sometimes you'll hear people call these high flow pumps. We like to refer to them as medium flow in the industrial hygiene world. So medium flow pump is probably a better description. But again, somewhere in the neighborhood of 1 to 5 liters per minute, depending on which sampling device you're going to use. So SKC basically has 3 medium flow pumps for that application. So at this point, it really becomes a matter of your preference and what you're looking for. And I won't spend a lot of time on this right now because I want to focus on the process of sampling and not necessarily selling, but I am the director of sales, so it's part of my responsibility. So just remember, you have choices when it comes to whether you want something very basic, like the pump on the far right, that really has a very simple user interface and on-off and easy to use. And then you have something like the AirCheck Connect, which also has a very easy user interface, but it has Bluetooth capabilities for remote operation, and it has programmability for setting different sample things to start and be the same each time. And then you also have data logging capabilities. And then last, to the far left, I think is probably going to be the most popular for this application, is the AirCheck Touch. And it too has a very easy user interface that's, has a color screen to make it much simpler. It also has data logging capabilities, and it has a CalCheck function for automatic verification or calibration. So just remember that you have choices. Next, you need to collect the proper sampling device. And Dusty talked a little bit about this, but to choose the correct sampling device and media, here are a couple samplers that you may have seen before, and Dusty even showed some of them, and some that you may not have seen. But so just to reiterate that each of these devices are used in conjunction with a pump, and you're pulling the air, you're pulling the sample through these devices to collect it on a filter. And then that filter will be sent to a lab for analysis. So when we talk about sampling media, that's what we're talking about. Sampling or sampler devices that pull air through sampling media for further analysis. We have 3 different types of cyclones shown here, and then we have the PPI that Dusty talked about. If you have ever used a cyclone before and dealt with the cleaning and the setting up, making sure that it stays vertical in the process, and then removing it from the employee without tarnishing the sample, you know the challenges. So the PPI addresses all of these and makes sampling much more practical and efficient. And most importantly, it does closely adhere to the ISO-CN curve that Dusty referred to several times. Regardless of what sampling device and media you choose, the designation of the flow rate is very important. So I know Dusty discussed this, but I don't want to miss it and be remiss in not mentioning it again. If your entire sample could be thrown out if you don't have the proper flow rate. There's a chance that it's still valid, but you would have to do a lot of homework and possible correlation to verify that with your lab. So just know that you need to make sure that the flow rate is correct, and it is not the same for all. As you see, for all 4 of these devices, you have the potential of a different flow rate. So you have to make sure that you're using the proper flow rate. As you can see on the PPI, it actually gives you the flow rate right on the front there. For this particular one, it's a 2 liter per minute, but there are 4 liter and 8 liter per minute options as well for the PPI. Now you need to select the proper working standard or digital rotometer, or what some of you may know of as a calibrator. So the industry has kind of moved away from the use of the word calibrator. So you'll hear us normally refer to it as a working standard or a flow meter. So the SKC Checkmate is a NIST traceable working standard or flow meter. It meets all requirements for air sampling regarding NIST certification, accuracy, and of course the performance. So as with the pump, you will be using the medium flow range, and the Checkmate has 3 different flow ranges: low, medium, and high. So you would be using the medium flow range. It is a 1-button operation, and it gives a running average on the screen. So that's nice because you have a real-time display of what's happening on the pump. So as you try to make your adjustments, you can see what's happening real time without having to use a separate tool or having a separate hand to make those adjustments. And it even has an averaging function that basically gives you 10 3-second samples for documentation on the form that Dusty showed an example of earlier. So at the end of that period, it gives you a firm number that you can look at for that information. And lastly, again, especially for this application, there is an intake port that allows the attachment of a cyclone. Some cyclones don't have a calibration adapter, so it makes it very difficult to check the flow rate or verify the flow rate if you're trying to put it in line. So you have the ability to attach it on the back side of the checkmate to perform your flow verification. Now that you have your pump, you've selected your sampling device and your media and your NIST traceable flow meter or working standard, now you're ready to conduct a sample. So I wanted to separate this part so that I could try to emphasize the ease of the process for each of you, that if you haven't done it before. So now just assume that you have all the proper equipment in place. This is what you're actually going to do to perform your sample. You're going to perform the flow rate verification, which is just basically checking to make sure that your pump is set at the right flow rate and that it's consistent with your flow meter. And then you're going to collect the sample for the designated sample period, perform a post-sample verification to make sure that nothing went wrong with your equipment during the process. Then you're going to document sampling details for your records, but also for the lab. And then lastly, you'll package the sample properly to send it to the lab. So first things first, you set up a sample train, we call it, and Dusty showed some examples of this in his presentation. So you see the worker there wearing the pump, and then the tubing, and then the sampling device, in this case, the PPI. So you're going to set it up exactly the way you would use it on the worker, like in this picture. Then, once you have it set up, you always allow the pump to run for at least 5 minutes before you perform the flow verification. This is extremely important, and I fear that this doesn't happen in a lot of cases, but you need to make sure this happens because this allows the pump to stabilize to the environment and to the flow rate. Before you put it on the employee though, you need to verify the flow rate. So you set up the pump, then you attach, in this case, the calibration adapter to the top of the PPI, and then you connect it to your working standard for your flow verification. Now, in this case, like I said, you have a calibration adapter attached. Sometimes you don't have an adapter, and that's when you would need to connect it to the intake side of your flow meter. Now, setting the flow, this is where you set it to the correct flow rate. In this case, it would be 2 liters per minute that you're setting to. So you check the reading on the flow meter and you make the adjustments on the pump so that the flow meter is reading exactly what you're looking for. You can't trust the display necessarily on the pump. You need to always look towards your flow meter for the proper flow rate. And sometimes you don't have the ability to adjust the display on the pump, so you really have to go 100% based on the flow meter. And then you would collect the sample. So to collect the sample, you simply remove, in this case, you remove the calibration adapter, and then you remove, if you're using a verification media or a surrogate media there, you would remove the PPI in this case, set it aside, and then unpackage the actual sampler that you're going to use on the worker and then send to the lab. You would attach it at this point, and then you would attach the sampling train to the worker, and then you would collect your sample for the designated period of time. And I know Dusty talked earlier about your sample period being longer than 8 hours. So whatever that sampling period is, you would attach it and sample for that period of time. Once it's done, you would remove the pump from the worker, turn it off, of course, remove the entire sampling train as well. And then you would perform a post flow rate verification. So very similar to what you did to perform the pre-flow setting and verification, you do the same thing after you're done. Again, this is to make sure that nothing went wrong during the process, whether your pump stopped working or there was such a back pressure buildup on the sampling device that the pump couldn't maintain the flow rate. So you need to always make sure that you perform this. And then you package the sampling media accordingly. You can see the PPI on the left You put the black cap back on, and then we actually provide a sticker that goes over those 4 holes. And then you mark all the pertinent information needed for your records, but also for the lab's use in the analysis. And then you send the sample back to the lab for the analysis. And that's really as simple as it is for the process of actual sampling. And because of technology and because of the calibration devices available, it's much easier to do than it had been in the past. Adjustments are done digitally in most cases, so it's a lot easier because you don't have the same amount of tools. Now, because we knew this was going to be uncomfortable for a lot of people not to know what they necessarily needed and to spend money buying it without being sure of what it was that was required, we have introduced a rental kit that kind of gives you everything that you need. So if you haven't done it before and you're looking to wade into the process, we have a rental kit that includes the pump, the flow meter, of course, the charging equipment that you need, but also tubing. We actually provide a surrogate PPI, and that's what I talked about earlier. That's one that you can use for the calibration process without exposing a sampler that you haven't put on the person yet, and a training video. And I put on there that there's a link or a QR code to that training video. And Dusty let me know earlier that he, on the final version of this presentation, there will actually be a link on there that you can click on to go view the video. And it kind of walks through a little bit of what I've talked about. And then lastly, Dusty also mentioned a little bit about real-time monitors. So this is an actual true dual purpose wearable monitor. And like Dusty said, they're not going to recognize real-time particulate monitors for compliance. But the interesting thing about this device is it is a compliance pump internally. So it is a constant flow pump, and it allows you to collect a sample in the sensor head. So while you're doing a survey or while you're out there looking to see as a screening tool where you might need to do additional sampling, you can also collect a sample on a filter that can be sent to a lab as well. So it's kind of a dual purpose monitor that gives you real time for screening, but also can collect a sample that you can send to a lab. All right, and that is it for me. And now if we have any questions.
Well, thank you guys. I appreciate all your time that you put into that. It was great. We do have quite a few questions that we probably won't be able to get to all of them. So just assure all of our listeners that we will reach out to you directly to answer any of the questions that we have that we can't get to. We will also send a copy of the presentation to all of the registrants. So you'll get a copy of the presentation that way. So let me start out first. What is the mechanism for reporting to the district manager, written or calls? Is it specified?
It is not specified yet. Based on some conversation that I've had, it'll be similar to what is already in place with Cole. There'll be a database where they will submit their results to notify them. Again, it's not been made yet, and we don't have any information on what that will look like yet, but it will be something.
Okay, great. Is periodic evaluation at 6 months a visual inspection for process changes, or is it an evaluation achieved through sampling?
It is a qualitative, so you're walking through the area and you are visually seeing what may have changed in the last 6 months that may impact sampling. Based on your evaluation, you may have to do some quantitative sampling, but in answer to that question, it's a visual look.
Okay. What is a B reader, and how many B readers are actually actively practicing?
A B reader is somebody who has been specifically trained, a doctor, to look at scans of people's lungs. Based on the information that I could find on the NIOSH site, like I said, there's 185 currently on there that are practicing. That was almost 1 year ago, so there may be a little bit more or a little bit less. But as you go through that list, there's only a couple. They're more heavy on the East Coast than the West Coast, which may provide some interesting results. Like there's one in Nevada, there's a couple in Utah, there's not many of them for sure out here
Okay,
west of
thank you. Thank you. That puts us at 11 o'clock. So we'll go ahead and end this. We want to respect your time, and we will make sure that all the rest of your questions are answered individually. And please know that you can reach out to any of us, any of your SKC or SKC West salespeople. Also, any of you that are going to be at the AIHA Connect next week, we will certainly be there. All of us will be there, and we're happy to answer any questions that you may have. So thank you very much. Hope you have a great day.